Hello, this is the first real tutorial of this FPS game, and in this tutorial, as you can see in this list, we will go through the vector3d class. This class will store a vector and the necessary functions to it. So like dot product, addition to the vector, assignment, so on and so forth. So all the important functions which we will implement. This tutorial will not result anything particularly interesting or anything graphically good, since it will only write a text to the screen and this end of the tutorial. Which I did is made a simple folder called FPS game 1 in my case, but you can call it anything you want, and I created the vector3d.h, vector3d.cpp and the main.cpp file, all of them empty at the moment, but we will type it now. So first of all, let's create this class. We need first the include guard, so multiple inclusion will not cause problems. Like this class was already defined, so use the if and def. So if not defined, vector3d underscore age, then we can type it right. Okay, then we can define the vector3d underscore age, and we will make it an and if right here. So multiple inclusion will not cause problems from now. So let's make the class called vector3d, and this class will need a few functions. All of them will be public, and all of the member will be public as well. So we need an x, y, and z coordinates to store. Since this is a vector, it will need an x, y, z coordinate to define it. This will define the direction of the vector and the magnitude of the vector. But I guess you already know that, since we used vectors in the past, just we didn't make a class for them. So we need constructors. So vector3d, an empty constructor, a vector3d, a constructor with two elements, so a and b. In this case, the z will be 0. Okay, we need a constructor with three elements. This will be often used, so float a, float b, float c, and yes, I can see the mistype. Alright, we need we don't really need destructor actually, since we don't dynamically allocate memory. We need now the important functions for this vector3d class, like float dot product. Dot product. Actually, we will not use the dot product in this FPS game, but it can be useful later on, or in your game if you want to use this class. You can freely use this class as you want. And we need to pass another vector, because the dot product is between two vectors. Basically, the dot product will get the cosinus between two vectors. May be useful in some situation, like later on you will see in the GLSL tutorial. That's how we will calculate the diffuse light. So we will need a const vector3d reference and call it, I don't know, vec or anything you want, vec2. Okay, we need a cross product. The cross product will return a vector3d object and call it cross product. That's right, and it will wait similarly another vector. The cross product basically get two vector, and it will calculate a vector which is perpendicular to both of these vectors. So basically get the normal vector of the surface, which can be quite useful, but again, we will not use in this FPS game, so maybe we will not implement it in this video neither, since it's a bit more complicated than a simple dot product. Okay, but which we will use is length. The length will basically get the length of the vector. Quite simple and straightforward. We will use the Pythagoras formula to get the length of the vector. We already did that in the past, if I remember correctly. Yeah, we did. Okay, and we need a normalize function, so void normalize. The normalize function will normalize this vector. So as we did in earlier, we get the length of the vector and divide x, y, and z both with the length of the vector, which is quite useful, since now it only pointing to a direction instead of a magnitude. So we can define a direction with it, like the direction of the zombie or the direction where the weapon, where we shoot a bullet, so the trajectory of the bullet. So it's quite useful. Now I will make a few functions which we will change the coordinate. So void change. This can be use to change the x, y, and z coordinates of the vector. We could use the assignment operator, so overloaded assignment operator. It really doesn't matter. We will not use that too often. If you want, you can make an overloaded version of this change function. I will not, so I will just make a simple float a, float b, float c. So it's quite simple, just made x equal to a, y equals to b, and z equals to c. Okay, we will make another overloaded version of this change function, which will get a vector3d reference, so vec2, and we will make a third overloaded version of this change function, which will get a vector3d object, vector2. Okay, and we could make the change x, y, and z too, so let me type that. So change x, float a. So this will just change the x coordinate, remain the other two coordinates the same. Really doesn't need this, since all of the members are public, so we could just use the name of the vector .x, .y, and .z to change it. It's really just to be, so nothing really important. The next function will be operator overloaded functions, so addition, subtraction, multiplication, and division, which could be quite useful, since we will use these actually some of these functions later on. So we can just use the plus sign instead of making 3 lines of code. Alright, so let's make them. So vector3d, this will be the return value, and operator plus, so it will add 2 vectors. So const vector3d and vec2. Okay, this will add the current xyz to the vector2's xyz. Okay, and similarly I will make the subtraction, subtraction, the multiplication, and the division. Okay, these functions will be quite the same. Actually, one more thing, we cannot multiply 2 vectors, we can multiply them with a number. So with a float number, we cannot multiply the vector with another vector or divide it, by the way. So this will be just a num, so number. That's right. And now that we have take care of this, we have 4 very similar functions, the plus equal, so not the plus but the plus equal, the subtraction equal, so on. So this can be useful, I guess. I don't know, I'm not really sure about that, what we have used and what we have not used in this FPS game, since it was quite a long time. Okay, the difference is that these will return the reference, since we don't need to give back the object, since writing like vec plus equal vec2, we don't really need to give back the vector, so it would be really not useful. But I think I have told that in the operator overloading tutorial, so I basically just almost do the same thing. Okay, and 2 more important functions are the is it equal, so the comparison operator, and the negative of the comparison operator. So it will return bool if it is equal and return false. So it's return true if it's equal and false if it is not. And the operator is the 2 equal sign. So is the vector 2 equal to vector 1? So const vector3d and vec2. And the opposite of this function is the not equal. It can be, I think it's pretty useful to able to compare 2 vectors quickly. And the last operator we want to override is the outstream operator, so the output operator. So whenever we write cout vec, we want the vec to write out vec.x, so the x coordinate of the vector, separated by space of y coordinate of the vector, separated by space the z coordinate of the vector. Exactly, that's what we want. So in order to achieve that, we have to override this operator. We cannot override it in the same way as we did with these kind of operators, because first of all it will search in the cout class and it try to find an overrided operator with so this overrided operator it did with the parameter of a vector3d object. Since it will not find it, it will search in the global space and try to find a function with overrided operator, which one parameter of this function is this cout, the other parameter of this function is the vector. So it has to be global. In order to achieve that, we will make it friend, although I believe it is not necessary now that it is friend, since the x, y, and z coordinate of this vector is public, so we could access them without without having to be a friend function. And I just realized that we haven't included anything. In order to override the the O stream, we have to include the IO stream since it's part of the IO stream. And the other include is the CMath header file, since we will use the square root function in this length function to calculate the length, and it is in the CMath if we don't want to write it ourselves, and we don't want to write it ourselves, so we will include that. Okay, the return value of this is an O stream reference, and it will rate. So we will override this operator. So this is the binary shift operator actually, which we will use to write out the things. And the first parameter of this is the cout, so the O stream operator. So std O stream reference and out. Yeah, right. Sorry about that, I had a call. Okay, so I think I just need the second parameter, which is a vector3d object. So vector3d vec, and I believe we can make it to a reference. I don't know, maybe. We will see. Alright, and this was all of the operator which we will need to overload. So this is all the function which we will need. I will just copy that in the CPP file and start to implement this. Oh, by the way, first of all, delete this line since that was just a demonstration. So copy this kind of line and paste it right here. And I will include the vector3d.h. So include vector3d.h. and we start to implement this function. Most of them is quite straightforward. One thing which we will need is called vector3d : so write this before every function name. I will do that in a moment. Let me pause. Alright, I did it. I added the vector3d : before every function name, and I deleted the tabulators before it. So now we are ready to make this function, actually the implementation of these functions. So whenever we have an empty constructor, I will just make a null vector, so x equals y equals z equals 0. So everything is just equal 0. Next off, whenever we have two coordinates, so we only want to demonstrate in 2 dimensions something, then I will set the x equal to a, the y equal to b, and the z equal to 0. I'm not sure how useful this function might be, so this constructor might be useful, might not, I don't know. Okay, and the most useful one of these, whenever we have 3 parameters, so x equal a, y equal b, and z equals to c. That's right. Okay, next one is the dot product. The dot product is quite simple. Whenever we have a dot product, it's basically just the x coordinates multiplied by the 2 vector, the y coordinates and the z coordinates are multiplied from the 2 vector and add that together. You will see in a moment. So what I do is just return x times the vector2.x plus y times the vector2.y and plus the z times the vector2.z. 2 I said, that z. So this is the dot product. I don't really want to explain how this comes or something. I don't really know, but this is how the definition of the the dot product is. Next one is the cross product. That's a bit more complicated. That's why I will not make this in this tutorial. But so just return something vector3d. So just return an empty object for now. But actually you can look up on Wikipedia, or the source code which I uploaded to the FPS game contains it. Not that complicated, but a little bit more complicated, and since we don't use this, we don't really need it. Next, the length, we will use this, so we have to implement this. This is the square root of x times x plus y times y plus z times z. This is basically the Pythagoras theorem, so the Pythagoras formula. Probably you're familiar with it. In another video I showed you how this works. Basically you get a right triangle and calculate the length of the c side, or how that is called, I'm not sure, never mind. So we will return this value. Okay, so this is quite simple and straightforward. If you know what the Pythagoras theorem says, it is so it is straightforward. Normalize. The normalize is basically get the length of the vector and divide the x, the y, and the z with the length. So float len, and this will equal to the length of this vector. Okay, and if length is not equal to 0, len is not equal to 0, because we don't like to divide by 0 because all kind of nasty thing happens, then x divided equal with the length, the y divided equal by the length, and z is divided equal by the length. That's right, the length. And that's about it. If the length is 0, that means it's a null vector, so we don't really normalize null vectors normally, so it's just a check. Okay, the next thing to do is the change. This change is pretty much the same as the constructor, so x equal to a, y equal to z, and z equal to c. Alright, the change vector is almost identical, except that I do that x equal the vector2.x, y equal to vector2.y, and z equals to vector2.z. That's right, it's pretty straightforward. I don't believe that need an explanation right there. This function, which doesn't weight a reference but weight the object itself, is pretty much the same. Okay, and the change x, change y, and change z function are not too challenging either. So x equal to a, and here y equals to a, and the change z function z equals to a. That's right, that wasn't challenging at all. Now finally some more interesting function. So the addition in case of vector, we add the coordinates, so we add the x from one vector with the x of the other vector, we add the y from one vector to the y of the other vector, and the z from one vector to the z from the other vector. I hope I said that good. I don't think so. Never mind, let's make it. So if we return vector3d object, vector3d object, as I said, and the first parameter is the x plus vector2.x, the second parameter is the y plus vector2.y, and the third is z plus vector2.z. That's it. We will use this constructor right here to make this vector free. Oh, this is what? That was an f. Let me go. Yep, that was an f. It's good that I noticed that. Alright, back to the business. So we add together the corresponding coordinates. That's the word I have looking for. Okay, the subtraction is pretty much the same, except we will not add it, but we will subtract it. What a surprise, isn't it? Okay, so subtract, subtraction, subtraction, subtraction. That's right. The multiplication is quite similar, except that we will not multiply by the corresponding coordinate, but we will multiply everything with the same number. So I will copy and paste it to save time, because the time is the money. Okay, so we will multiply it by num, multiply it by num, and multiply it by num. And that's right. Okay, the division is similar, except we'll make a simple check. If we want to divide by 0, we will not do it, because we don't like to divide by 0, still not like to do that. So if num equal to 0, not equal to 0 I wanted to say, because we don't divide with 0, then we will divide with the num, divide the num, and divide the num. As if we want to divide by 0, let's just return something, because we need to return, since we set the compiler this will return a vector3d object, so it will want us to return with something, so vector3d, and just return with a null vector. So we will use the empty constructor, which will create a null vector right here. Back to the business. The plus equal, minus equal, multiply equal, and divide equal is very similar. The difference is that we will not create a new vector, but we will use this operation, but we will run the, or not, no, that's not the correct word. So we will use the operation, no, that's not either. Instead of a new vector, this vector's coordinates. So x plus equal vec2.x, and similarly the y and the z. So y, z, z, y. That's right, so we add together, and we will return, because we said that we will return reference, so we can do something like that. Vec plus equal vec2 plus equal vec3 plus equal vec4. Why would we want to do that? I have no idea, but if we want that, we can do that right now by adding return the this pointer, actually the dereference this pointer, so it's not this pointer, this is this class, but actually we said that it is a reference, so it is reference. Clear? I don't think so. Alright, and then we have almost the same thing to do with the subtraction. So in case of subtraction, we subtract. What a surprise. And in case of multiplication, we multiply with the num. So num, almost num, num and num, and I know that there is an addition operator right there, and I will change that in a moment. So multiply, 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 and that's correct. And the division is almost the same as earlier, except oops, now we need to check if we want to divide with 0, since we still not like to divide with 0. So if num not equal to 0, then we will do the division. So divide, divide, divide. Alright, so just close this curly brackets because I just got a call. Actually this was the second call since I started to make this video. Yes, so back to the business. We have to make 3 more functions till this tutorial ends. The equal, which is quite simple, the x equals the vector2.x, and the y equals the vector2.y, and the z equals the vector2.z. So return, and x equals to vector2.x, and y equals to vector2.y, and z equals to vector2.z. That's correct, and that was all things to do for this. The not equal is actually the opposite of the equal, so we can make something like that, that this equal to the vector2. So basically now I call this function and I negate the negate. So I use a not operation on the value of this, and I think this should work. By the way, it is bad in the other, so the fourth file, the not equal operator, I should have used or instead of and. Never mind. So actually I have a cheat sheet right here, so I can see that what I typed, and now I can see that it's wrong. The last of all is to write out some value, so we will write it to the out. This is actually what the parameter ostream type, and we will write the vector.x and the space vector.y space and vector.z and the new line, so std end line. That's correct. So now just return with the out, and we should be pretty much ready. Okay, we don't really need this main file right here, but for testing purposes I will just leave it right here. So include iostream and include vector3d.h. That's correct, and I will just create a main function and quickly create a few vector and test out the properties and the functions of the vector. So vector3d vec1, and this will be a null vector, vector3d vec2, and this will have 1, 2, 3 value. Let's just write out to see that is actually this overloaded ostream operator, so this works or not. So cout vec1. Okay, and actually write out the vec2 as well. So now we should see 0, 0, 0 and 1, 2, 3 on the screen in separate lines. Okay, let's write out something else, like write out the length of the vector2. So vec2.length. Okay, and make a new line and normalize the vector2. So vec2.normalize. Okay, and write out the vec2 again, so vec2, and actually I write vec21 here, so 21, and I didn't write the C right here. Alright, what else do we want to find out if work or not? Dot product, I'm pretty sure that works. Okay, oh, addition, of course, how could I forget? So let me make a third vector2, so this will be vector3d, and this will be vec3, and this will be 6, 5, 4. Okay, and let's add together vec2 and vec3, so make another vector, caps lock. So vector3d, this will be vec4, and the vec4 will be equal to vec2 plus vec3. If everything goes correctly, this will be 777, the value of vec4, but we will write out vec4, and pretty much if the addition works, the other works as well. So one more thing, vec4 plus equal vec2, and write out the vec4 again, see out vec4. And now we are ready to test how many errors did I make. I think 20 should be a quite good guess, but let me try to compile this thing. So g++ star.cpp, so every cpp file, and we don't need any flags right now. Alright, so end line and cout, so I haven't used the std : I guess correctly. So std : and let me just write here as well, and here. Okay, and one more thing here. Okay, 150 friend used outside of the class definition. That's correct. We only need to use the friend inside the definition, the header file. We don't need to use the actual implementation, so the friend keyword OSD. Alright, and try again. Oh, one last error remains. Must take exactly one argument. Oh, the problem here is that the vector, that it is not the part of the vector3d class, since it's a friend of this vector3d class, so it is a global function, not part of this vector3d class. So we have to delete this vector3d : from right here. And now how many error? 0 compile error. How many runtime error? We will see. Okay, 0 0 0 1 2 3, it's correct till now. Okay, then we wrote out the length of the vector2. How the hell should I know that? Okay, probably good enough. Okay, the normalized vector, I don't know, and additions, I think it's working. I don't know actually. I just think it's working. Okay, that was about this tutorial, and in the next tutorial we will again quite boring subject. We will create the collision plane, collision sphere, and the collision class. And then we can go on to the camera, and which will be quite simple, the object loader modification, and then the interesting things comes, which will involve graphics. Thanks for watching, and have a